Today we're going to be talking about pointers. What is a pointer, you ask? A pointer is an object, just like an integer, a double, or a char. But instead of having a value of a number or a character like integers, doubles, and chars, the value of a pointer is a memory address. Hence, it's pointing to another object in memory. Let's look at an example to see how pointers work. So if we look at the first two lines in our function, we see that we're initializing two variables, a and b. So in memory, I'll draw a and b. Their values are 1 and 2, and they have addresses. So we'll say, for instance, that a is at memory address 1000 and b is at memory address 1004. These next two lines are things you may have not seen before. This means we're creating a pointer. The integer right here means that we're pointing to an integer object, and the star signifies that it's a pointer type. So we could also have a double pointer, and that means you're pointing to a double object. Back to our example, we're creating two pointer objects, which we will label in a very similar way. They also have addresses. We'll say maybe 2000 and 2004. Now PTR1, the value of PTR1 is the address of A. Ampersand in this case means get the address of. The address of A is 1000, and so PTR1 has a value of 1000. Another way to represent this is by drawing an arrow to what the pointer is pointing to. In this case, it's pointing to A. For PTR2, we are saying that its value is the address of B, ampersand meaning get the address of. In this case, the address of B is 1004, and so that's the value of PTR2. Again, I'll draw an arrow to show where it's pointing to. Now we'll look at a couple examples to see what the ampersand, the star values mean for regular objects and also for pointers. So first, we know this really well. So if we print out an integer, it will print the value of that integer. In this case, a is 1, so we'll print 1. This next line says, print the address of a, ampersand, of course, meaning get the address of. So the address of a is 1000, so we print 1000. Now we'll look at a pointer. So when we ask to print a pointer, we're printing the value of that pointer. In this case, the value is the address 1000. So again, we print address 1000. Now the star in this instance means dereference. Dereference means that you're going to go where your pointer is pointing and get the value that you see there. So in the case of PTR1, we're going to go to the address of 1000 and grab the value of 1 and print it. This last one means get the address of PTR1. And sometimes it's easy to forget that PTR1 also has an address, in this case 2000. So we're going to print the address of the pointer, which is 2000. This next line, we're setting PTR1 equal to PTR2. That means that now, instead of pointing to object A and having an address of 1000, PTR1 is going to have an address of 1004 and point to object B. Now, when we dereference PTR1 and print it, we go to address 1004 and grab the value, which is 2. This next line, again, is using the dereference star. So we go to address 1004, but instead of grabbing the value, we're setting the value. We're setting the value equal to 5. So we set B equal to 5. Now, when we go to print out these three lines, we go to dereference PTR1, and we see that the value is 5. We go to dereference PTR2, and it's also equal to 5 because PTR1 and PTR2 are pointing to the same value. And then finally, when we print B, we see that B is also going to be equal to 5 because B's value is changed by PTR1. This is a very useful property of pointers, meaning that you can change something's value without actually having to use the object's name.